Welcome to Summit. You've already probably been welcomed, but again, my name is Mike Mayhew. I'm with a company called GoTo Group. We're a platinum expert partner with Atlassian, and we have been so for over 10 years. We predominantly help companies develop software better through best practices and tooling, and it's as far as being cloud native and DevOps and microservices and all that, we're kind of like State Farm. We've seen it all. And we've definitely seen how to not do it. So hopefully today we'll talk a little bit about how to do it right. How many of you are deploying applications to a cloud? So a good number of you, almost probably half. Oops. There we go. So whether you're deploying to the cloud now or you're looking at deploying to the cloud in the future, we're taking a journey today to how to be cloud native. But it's really about the destination, and the destination is the same. We're trying to deploy applications to somewhere. And so today we're going to walk through how to be cloud native, and we're going to focus on 3 verticals. And those verticals are going to show how we can deploy faster with better precision and more clarity. So the agenda today, first we're going to talk a little bit about the journey itself, and then we're going to go into what it means to be cloud native. These days, I think Forbes just wrote that cloud native is the norm, is the normal now. In 2018, they actually said that, so it's probably definitely the norm in 2019. But then we're going to focus on those 3 verticals: DevOps, microservices architecture, and containers, and then we'll kind of come full circle and bring it all together. So what are we leaving behind? We're leaving behind waterfall. Hopefully most of you, if not all of you, have already transitioned to an agile process. We're leaving behind bare metal servers. We're leaving behind locked-in frameworks and things like that around your applications. We're trying to be framework agnostic if we can. And so the 3 things that we need to be cloud native are DevOps, and maybe you're already practicing DevOps, but today we're going to take some different directions in our DevOps process, and then also microservices architecture, and we'll talk about what it means, what microservices means, what the architecture looks like, and also what it means to breaking up your data structures. And then probably most importantly is the container aspect. So we're going to talk about Docker and how to deploy Docker images to the cloud and Kubernetes. So this quote kind of captivated me. Digitally advanced enterprises are 8 times more likely to grow share, but they still lag behind digital natives. So as I said earlier, we've kind of figured out how to be agile. We know how to iterate. We know how to develop software, and we're fast at doing that. We can break down our requirements. But where we see companies struggling today is how to deliver the software and deliver code fast. And today you'll see in some slides coming up that it's not just that we're delivering web applications, but we're delivering RESTful services and other aspects of the application. So speed is a must-have to do digital business today. As I said, digital innovation today is not just a web application. It's also mobile devices, wearables, AI, chatbots, blockchain, and machine learning. So you're not just presenting your application in one way to your audience. And then there's the disrupted business models. Switching to a culture of organizational agility, we have done that. Hopefully you guys are all practicing Agile at this point. But then it's being flexible while maintaining a fast pace, not a face pace. I knew that was going to be there. So it's really about being fast, but also being precise and being able to repeat how you deliver your applications. So let's take a look at what it means to be cloud native. So cloud native architecture is built for running in the cloud, right? That you would think. But it's also not just on being built for the cloud, but it's not where we're going to the cloud, but how it's being built for the cloud, sorry. So cloud native is about how applications are being created and deployed. It's the frameworks and the tooling that we're using to build our applications, the automation that we're building within our CI/CD pipelines that makes our application cloud native and take advantage of the technologies that cloud can provide. And that's where we improve on speed, redundancy, and the things that we want to get out of being a cloud native application. So it's not where we're going. It's not that we're going to AWS or we're going to Azure or even a private cloud, OpenStack. It's how we're getting there is the difference, and that's what makes us cloud native. So let's take a look at some of the languages that are considered to be modern-day cloud native languages. And these are all web languages. HTML and CSS, obviously, Node.js is very popular these days, but you don't see any Fortran or COBOL or older languages in there. And that's because we're taking advantage of lightweight languages. Most of those languages up there are scripting languages, and those are going to be more suitable for the cloud. So the big key is cloud native delivery. And the way that we do that is through automation. So we'll talk a lot today about improving your automation of how you deploy your applications. It's not just continuous integration, but it's also continuous delivery. And it's not just delivery to test environments, but delivery to production environments. Your applications need to be reliable, repeatable, and proven. And we do this through, again, CI/CD and using the right tools and the right methods to build and deploy on the fly at a fast pace. And these need to be known working processes. So again, we're using our configuration files based on the technologies that we're using, and these are repeatable. We've seen them work, proven in the CI, and then we're going to see them work in the CD. But this is going to require orchestration and automation. Orchestration and automation are two very important aspects of deploying your applications to the cloud fast. We also want our applications to be modular, which is a difference. Cloud-native applications are modular. The functionality is broken down into microservices that represent business functionality. So when we talked about Agile in the past, we talked about breaking down our requirements into smaller pieces. And this enabled us to iterate over our development cycles and have faster release cycles and move quicker and be more focused on smaller pieces of functionality that we're trying to deliver. It's similar to delivering a cloud-based application. We want to break our application into smaller pieces that are based on business functionality. So that's going to be a change of architecture of your application to be suitable to be cloud native. We also want our applications to be loosely coupled. Loosely coupled applications are going to be applications not tied to infrastructure, so we're not configuring servers. There's no tied to any particular operating system or any type of framework that's on the server itself, so there's no more operations maintaining staging environments and things like that. On-premise applications are stateful because they rely on those things. So their state is being maintained by infrastructure that's configured and maintained either on bare metal servers or even it could be virtual. So we want to loosely couple our applications to where they can be deployed, and it doesn't matter what the operating system is or what the back end is. So here are some key benefits to being cloud native. So we have auto provisioning. It's kind of like an architectural one-way. We want our developers to focus on coding, and the automation is going to happen with our CI/CD pipeline. So it's going to also auto-provision our application. So we're not just deploying, doing CI/CD and coming up with some artifacts that are in a repo that somebody's going to pull out and then deploy manually. We're actually auto-provisioning our code into a container, into an image, and then deploying the whole container itself. This also allows us to be elastic. Our storage is elastic. Our resources are elastic. We can add and subtract resources and add and subtract anything that we need to support our application. And then there's auto redundancy. As we break apart our application and we break apart our data structures, the redundancy in the cloud is amazing. I mean, you can fail over, and now with microservices, we can fail over just a portion of our application as we do patches or release code, not affecting the other modules. And then finally, the most important thing is precision, which, you know, if you think about deploying your applications faster, you're going to have an accident, you would think. You want to be more precise than you were before in a monolith type application architecture. But the cool thing is that we can be very precise because the automation is coded ahead of time and scripted ahead of time. So let's talk about DevOps. How many of you are doing DevOps? Good number. And DevOps is kind of a strange word. It became popular. We used to call it configuration engineering, and you know, there were other names for it. We kind of merged operations and our developers. And back in the day, you probably, maybe even today, you have people that are maintaining your servers, and you can't deploy to them without getting approval, and you go through all these hoops and status meetings and go through QA to get your application deployed. IBM made a fortune on that model. They, you know, maintained the servers and charged you a lot to get your code up there. But DevOps kind of removed a lot of those barriers, and it also enabled agile teams to speed up. And today, I think a lot of companies are doing CI/CD, but they're doing it, you know, up until the staging environment. They're not doing it to production because still companies are scared to let something automated deploy their code to a production environment. But we're going to take a look at that today. So we're going to see some differences in what standard DevOps practices are. So here's another quote. Within a year of Amazon moving to AWS, their own thing, engineers were deploying code every 11.7 seconds. And this is to production, on average. And this amazes me because this would have scared the hell out of me years ago when I was deploying a huge policy management system for an insurance company. There would be no way we would be able to deploy our monolithic application in or deploy any code in 11.7 seconds. It would take that long just to make a decision, let alone get code all the way from development to production. So this is definitely something to try to achieve maybe in the future or in the near future. But it's not necessarily, that's extremely fast. And to be able to do that, we're going to talk at some of the things that Amazon has done and some of the concepts that they're using. But this is really about speed and precision, and they've done it here. So DevOps, this is kind of a review, but DevOps is culture, practices, and tooling that supports the ability to deliver applications at high velocity. Again, we were all trying to figure out how to get requirements faster and to break them apart and to develop faster and code faster, but also at the same time improve our precision with quality assurance, test automation, and those things. And still we're doing that. And we've changed the culture. The culture has changed about how teams are built and made up, and the types of people that we hire and the skill sets that we have to be able to perform DevOps duties. It's not just a developer anymore. We typically at GoToGroup, we look for full stack developers that know the whole stack. And I think DevOps, sorry? I think DevOps people are in high need right now because of this. But again, it's still about speed. So what is cloud native DevOps? We're still going to do CI/CD, so we're still talking about continuous integration and continuous deployment. But we're going to, again, change the architecture of our application to be a microservices type architecture, which we'll dive into. But also the infrastructure as a code. This is key to the provisioning and the speed and getting your application into the cloud and being cloud native. The reason why it's key is because if you are familiar with Docker, or you're familiar with Kubernetes, or Helm, or any of the technologies that help you deploy code to to the cloud or to any cloud native environment, you're going to be using those YAML files, Docker files, Bitbucket pipeline files, Bamboo files. They're all YAML files, as well as Kubernetes and Helm charts. They're descriptors that are kind of pre-describing what your environment and what your technology base and your technology stack is going to be and how your application is going to be containerized and deployed into a Kubernetes cluster on a cloud, as an example. And the other thing is the monitoring and the logging. No longer are we just monitoring production and looking through the logs for words that alert us and sending out a notification. We want constant feedback from our customers that are using our application. So this could come from many ways. This could come from us monitoring our application itself. It could come from monitoring the deployment of our application and monitoring our pipelines. It can also be from people submitting issues or submitting support that comes through our OpsGenie application or our service desk. Either way, we need to be monitoring and logging and taking these changes and iterating and moving these changes back into production as fast as we can to keep your application modern and up to speed with your customers. So infrastructure as code, best practices. And these are just words that kind of go along with best practices around doing infrastructure as code. Remember, we're kind of dynamically creating and provisioning not just our application, but the infrastructure that our application runs in on AWS or on some cloud. So we're going to manage infrastructure with source control. So we're checking in and out our Docker files and different YAML files that is going to descript or describe our infrastructure. And then we're still going to be doing applied testing, unit testing, integration testing, and functional testing. But today we're doing a lot of that more automatically, right? We're auto testing. I think Atlassian is high test coverage, 90, I don't even know what it is, 98, 99 point something % test coverage. Very few actual QA people. So there's a lot of automated testing. And then code, documents, infrastructure, and state. Those are all going to be key best practices. We want to have the same state for every container that we deploy. And it needs to be the same every time. And then collaboration between dev and ops. See, that's the thing that's changing is it's not just DevOps. We're starting to see a separation. It's almost like no ops because the operations folks are not focusing on the deployment of the application. They're focusing on the governance around the platform that you're deploying to because they know when we deploy to production, it's going to be the same every time. But they need to maintain the Kubernetes cluster and the governance around where and how the applications are getting deployed and then the scale around that. So what we want is we want teams to focus on code. We want teams to live in Git, and we want them to be focused on the functionality that they're trying to deliver. And that's why microservices architecture, by splitting apart the pieces of the application based on business functionality and having the developers and the teams focusing just on Git, there's no more distractions. They're going to be able to code faster with more precision and more focus. So let's talk about GitOps. Have you guys heard of GitOps? So GitOps is all about YAML and configuration files and having the developers interact with Git, and by the actions that they do in Git, that basically will trigger automation to happen. So it's really continuous delivery, the CD part of CI and CD, that meets cloud native. And so the pipelines are a perfect model for secure. We'll talk about security, but we just took it to another level because now we can scan containers for security, not only scan our code, but scan our containers in our environment on the fly. Cloud native CI/CD pipelines, fast times to deployment and recovery. Again, that word fast. We're trying to deliver fast. We're trying to get changes out to our customers, so we are not lagging behind our competition. And then the ability to roll back. You can't really do that if you're running on bare metal and you've got a monolith application. There's really no rollback. There's a redeploy, there's a rebuild, and that takes time. And so then you have downtime. So it's about being able to roll back, being stable, reproducible rollbacks. We can roll back a module and redeploy it in seconds, and it doesn't affect the rest of the application. And then we can revert. And so monitoring becomes key. Again, it's not just monitoring production, it's monitoring the whole pipeline, the whole process. It's monitoring your application and the frameworks around your application. And you'll see what I mean when we start to talk about containerization and how we maintain our containers in a Kubernetes cluster. But we're essentially monitoring the containers themselves, the security, the performance, and even the scalability of our services. So we're going to go into the microservices architecture now. How many of you are deploying microservices? That's pretty good. That's a good number. Surprising. Because my microservice architecture is the norm now, they say. All right. So we can't talk about microservices without mentioning Netflix. So we've talked about Amazon, now we're going to go to Netflix. In 2008, I know that's a long time ago, but Netflix was still operating as a monolith, and a single semicolon brought down the whole Netflix website. That's kind of scary, but you can probably see how that would happen. So that's something that we don't want to have today, and that's why Netflix is now operating on a microservices architecture. Obviously, they have to serve up streaming content to millions of users at the same time, so they need to be able to scale. They need to be able to get code changes out to their customers quickly. They cannot have any downtime. And they need redundancy and all these things that we're talking about, and they need precision. They can't have a semicolon make it to production. So they've adopted microservices, and I've never had an issue with my Netflix. I don't know about you, but since then anyway. So let's look at some microservices basics. So we want them to be highly maintainable, just like any application, and easily maintainable for that matter. We want them to be loosely coupled. So like I said, it's almost like Jira Data Center. If you want to do an upgrade, you can do an upgrade to one node and still serve Jira to your people. We want it to be loosely coupled so we can make a change to our inventory management module of our application, but the rest of the application still functions. Independently deployable for that same reason. We can deploy one of our services, one of our microservices, and not affect the other services. And then we want those services to be organized around the business functionality or business capabilities. And that's common sense, right? I mean, we want to, if you remember taking business requirements before Agile, you might get a 30 to 60 page business design document, and you'd give that to developers or to the development team, and they would try to interpret that and then start to develop on it. And then, of course, you get all the way to the end, and QA got pushed to the wall, and then they'd say, that's not exactly what we meant. So let's go back and do that again and make the changes. This is just like Agile, breaking it apart and having focus on the pieces and parts at a smaller level. So we don't do that. So we make sure that we're delivering what we anticipate to deliver. So we're definitely going to be more organized around the business capabilities when we break apart the architecture of the application. And also, it takes away a lot of the business logic in a middle tier service layer. So let's compare what a monolith application looks like to microservice application architecture. So here you see a browser accessing Apache, it could be Nginx. And this application is a Java application. It's deployed as one WAR file with some jar files, as you typically would expect. And they have services. I mean, those are services, could be middle tier services or RESTful services. And then there's a storefront UI, model view controller, design pattern here. And then there's a single database. It's classic right there. We've been doing it for years. It works, and it may be best for some folks. But let's compare it to what a microservices architecture looks like. So now we have Because remember, we're not just developing or deploying web applications anymore. We're deploying web applications that support watches, phones, AI, chatbots, whatever, blockchain. So now we have 3 services in this case, still being deployed to Tomcat, but we have a web app on the front end, so we have our view, and then we have an API gateway for our mobile stuff, and we're deploying those services independently, so they're modular, they're separate, they're isolated. But the interesting part is that we've also separated our data structure. So they're completely independent of each other, and if there's any business logic that needs to happen between the services, it's going to make a call to its own REST service or the other REST service, and the data stays isolated. This is why we can deploy the accounting service or make a change to the accounting service without affecting the inventory or the front end of the application. It's all about speed. So we're just kind of piggybacking on technologies that we've picked up on our journey. It's an evolutionary journey. So now it's time to divide and conquer and split up those data structures, which is what we just saw. You're not just going to be able to split your application into services, you're also going to have to split your data structures up in order to do microservices. The other thing we want to do is we want to plan how the application will behave if one service is down, and this is that redundancy part. We want to make sure that if the front end can't access the inventory service, that how is that going to behave? So you want to plan ahead of time the way that your application is going to work if a service is down for a second or two. And so what are the advantages of microservices? There's no vendor lock-in, so you're not tied to a server or any kind of server architecture. You're not tied to something like MuleSoft or whatever, any kind of framework. There's fault isolation. So like I said, the practice of designing systems that limit negative consequences when bad things happen. So we're planning for bad things to happen. That's why we're separating our services. If one's down, we're planning ahead of how the application is going to respond. And then the clarity. Smaller, more focused services, just like smaller pieces of a requirement broken down in an agile process is going to be more clear to the team, and they're going to be able to focus on it a lot better. So tying this together is how do we get our application, now that we've broken it into a microservices architecture, we're doing CI/CD, we're iterating quickly. Again, the struggle with companies today is how do they deliver it just as fast? And so that brings up containers. How many of you are using Docker? About half, maybe a little less. So everything at Google runs in containers. Docker, for a while was used by developers. It's a quick way to spin up dev environments and test your code out on your machine and even maybe run it in the cloud. But until recently, there weren't that many, and I say recently, in the last couple years, companies running their production environments in containers, but Google does. So some container benefits. They're well-defined. We describe them ahead of time. They're isolated runtimes, so they're isolated, there's no changes, they're dynamic. They're packaged by Docker files. They're promoted through CI/CD, so here's that automation again. So not only are we automating our build, but we're automating our deploy and the environment and the infrastructure that goes along with it. It's fast provisioning. That's my favorite part. It takes, if you spin up a VM on AWS, it takes minutes. You can deploy an application and spin up a container in 3 seconds. That's the difference. And you can do it from development to production. So your descriptors, your descriptions of your environments are different, and they can trigger based on your CI/CD pipeline. You can have decisions. You can have governance around who and how, what merge makes it build and go to production. But again, all of these things happen in seconds and not minutes. And it allows you to scale. And I think a lot of large companies went to the cloud because to scale costs a lot of money, and it costs a lot of data center expansion. So one thing that it does bring is complexity. So if you were to have a single microservices application with, as the example showed, 3 services, and you were to go through a development cycle of a 2-week sprint, you would probably spin up anywhere from 50 to 100 containers, and some of them would be disposed of. But there's a lot of activity. There's a lot of containers being deployed. There's a lot of things to look at. There's a lot of things to monitor. So many services needing to be deployed independently. The number of deployments increases dramatically. It's definitely dramatic. And then so the monitoring and the logging becomes complex. But this is why we have best practices and tooling around these things and frameworks to where we can monitor the application's performance, how many containers are on our landscape, and provide governance, again, around the containerization, around the platform that we're deploying to, which typically is Kubernetes. Kubernetes is like the default cluster environment to deploy containers to, and using the tooling around it to deploy containers. So Kubernetes is a container orchestration system for automating containerized application deployments. How many of you are using Kubernetes? So yeah, there's other platforms out there, but definitely Kubernetes is probably the de facto these days. Google came out with Kubernetes, so it's probably cool. It has a weird name. I think it's actually pronounced Kubernetes, if it's to be correct, but everybody calls it Kubernetes. We've done a lot of stuff with Kubernetes at GoToGroup. We have some very large clients where we're kind of helping them do microservices architecture, improve the speed that they can deliver their applications. And I'm talking about big companies, to where you have maybe 50 different teams across the landscape, and they're all doing things differently. They have different versions of their CI/CD pipeline software and applications and tooling. And we're trying to help them bring that all in together. And you can imagine a company that size, they would have tons, once they get to the containerization aspect of deploying their code and packaging it in a container and deploying it to Amazon or wherever, you can imagine the number of containers that are being spun up and the kind of governance they need around that, and how they scale that, and how do they monitor performance. It gets very complex. But Kubernetes is awesome about that. First of all, orchestrate and monitor those containers like a boss, because you will need to do that. And this is that separation again. It's not DevOps, it's dev, and then there's the ops. And the ops is going to be worried about that infrastructure that's hosting the Kubernetes cluster and all of the containers and the things like that. So there's that aspect. And then there's the security aspect. There's 2 different types of security. There's the security on the cloud itself, and then there's the security on your application. The code, is your code secure? And then there's the security on the containers that you're deploying to, and you're deploying the containers to the cloud in. So we use the Docker files to again to describe the containers that we're going to deploy our applications to, and the build process to produce the necessary Docker images. And those images are versioned and stored Docker Hub, and in Docker Hub or Nexus or Artifactory. And so with Kubernetes, we're managing the deploying and the scaling and the updating of the applications. If you have an application the size of Jira deployed in a container on a Kubernetes cluster, you can change code and redeploy that application in 3 seconds using Helm. If you were to try and do that on a virtual server on AWS, again, it would take minutes. And then finally, back to that monitoring again. We're not just monitoring our application, we're monitoring the containers and the services that you're deploying that are running in a container on the cloud. We're still monitoring all these things, and we can do that with Kubernetes. And we can make changes to our Kubernetes cluster on the fly. So looks like we're going to have about 5 minutes for questions after I say one more thing. Putting it all together. So we were on a journey. It was like a hiking trip or a road trip, and we kind of picked up some things along the way. And some things we already had, but really what we did is we rerouted. We were going to the same destination to delivered code, but we rerouted and we picked up some cool things along the way to make ourselves cloud native and to be able to deploy faster with better precision. And that's Agile, microservices architecture, cloud, DevOps, soon to be no-ops, containers. We've isolated everything, so it's easy to deal with and monitor the different aspects of it. And then we've provided governance around the entire landscape. All right, we can do Q&A now. 4 minutes, 40 seconds.
So if anybody has a question, just raise your hand and I'll give you a microphone.
So how do you connect like containers with the serverless movement recently, like Lambda functions and stuff like that?
To what, Lambda?
Like, yeah.
To serverless, how do you connect them?
Yeah, I'm not very experienced with containers too, but I'm curious now in a pod, should I focus more on like Docker and stuff, or should I just focus more on a Lambda functions for like the microservices and everything?
I would take baby steps, but it depends on the type of application. But I would first focus on the architecture of the application. You know, think about it, how your teams are going to work. And there's going to be, like we talked about, the disruption of the culture. And I don't know how big your company is, but the team dynamics is key and what people are focusing on. So I would focus on the architecture application first and break it apart into a microservices architecture. And then I would focus on having best practices CI/CD pipelines and forget about the cloud, but just how you're doing CI/CD and building your applications to where they're deployed in containers. And then from there, you could maybe look at serverless. But first, I would get to that point first.
Hi. Can you explain the difference between the Fargate service in AWS and Kubernetes? Do you
What
have
was
any
the first part?
experience with the? I went to the AWS summit recently, and they were talking about a new service that they offer, which is called Fargate,
Yep.
which is a fully managed container
Yeah.
management service. And I gathered that that means that it's basically in competition with Kubernetes.
Right.
Do you have any experience about whether
So that's a
one
good
would be
question.
better?
He's asking about the Fargate AWS service. So all the clouds are coming up. So one thing, being cloud native is not about being on AWS or Azure, but all of these cloud companies are building tools and tooling to make you be able to deploy easier and faster. It's all based on having your apps being in containers and being kind of broken apart for best practices. But it probably is Kubernetes behind the scenes. But really the bottom line is it doesn't matter if it is Kubernetes, but what you're doing and what they're doing is the same. It's you're deploying your applications that have been deployed in a Docker image, and they're running in containers on some sort of virtual cluster that can allow you to be monitored and to scale and have lots of deployed containers. But I bet you it is Kubernetes in the back end.
So I think that we're out of time, but guys, feel free to just chat with Mike after the session, and I'm sure he'll answer more questions. Thank you so much. Thank you for coming, and please rate the talk.